Welcome to the session on number patterns. In this session, we're going to be looking at sequences. The objectives for this session are to introduce some number patterns, define an arithmetic sequence, and find the nth term of an arithmetic sequence. We're now going to take a look at some number patterns. The first of these is square numbers. These involve the squares of numbers. So, we have 1, 4, 9, 16 and 25 and so on. The simplest case, of course, is 1. Then we have 4. This forms a square by arranging the dots as shown. The number 9 can also be arranged as a square by arranging the dots as shown. And similarly with the number 16, this is a 4 by 4 square. And the number 25, this is a 5 by 5 square, and so on. Now let's take a look at triangular numbers. These numbers can be represented as dots arranged in an equilateral triangle. So we have 1, 3, 6, 10, 15, and so on. The first triangle is simple, it's just one dot. The next triangle is as shown, one dot at the top and two below to form an equilateral triangle. The number 6 or 6 dots can be arranged as an equilateral triangle as shown here. And similarly for 10 dots being arranged as an equilateral triangle here, and now for 15 dots arranged as an equilateral triangle here, and so on. A rule or formula for generating these numbers is Tn equals n over 2 times n plus 1. When n equals 1, we have that T1 equals 1 over 2 times 1 plus 1, which is equal to 1. When n equals 2, we substitute in similarly n equals 2 into the formula to give T2 equals 3 as shown. Similarly, when n equals 3, substitute in n equals 3 into the formula to give T3 equals 3 over 2 times 3 plus 1 equals 6. And for n equals 4, similarly we have T4 equals 10, and so on. And now for geometric sequences. In a geometric sequence, each term is obtained by multiplying the previous term by a constant value. So for example, if we have 2, 6, 18, 54, 162 and so on, can you see a pattern that's emerging? Let's take a look. If we begin with 2 and we multiply by 3, we get 6. We multiply this by 3 to get 18. We multiply this by 3 to obtain 54. And we multiply this by 3 to obtain 162, and so on. And now for the Fibonacci sequence. In the Fibonacci sequence, each term is the sum of the two preceding terms, starting with 0 and 1. So we have 0, 1, 1, 2, 3, 5, 8, 13, and 21, etc. So how did we get this? If we begin with 0 and 1, as stated, and we add these terms, we get 0 plus 1 equals 1. Then we add 1 and 1 to give 2, add 1 and 2 to give 3, add 2 and 3 to give 5, add 3 and 5 to give 8, add 5 and 8 to give 13, and add 8 and 13 to give 21, and so on. An arithmetic sequence is a sequence in which the difference between consecutive terms is constant. We're now going to take a look at some examples. One example will be of an increasing arithmetic sequence, another will be of a decreasing arithmetic sequence, and another will be of a sequence which is not an arithmetic sequence. Let's take a look at the first example. An increasing arithmetic sequence example can take the form 3, 7, 11, 15, because notice that this is increasing by the same constant. We're adding 4 each time as shown. Now let's take a look at another example. A decreasing arithmetic sequence example is 27, 22, 17, 12, and so on. Notice that this sequence is decreasing by 5 each time, so we're subtracting 5 to get to the next term. And now for the third example. A sequence which is not an arithmetic sequence can take the form 3, 5, 9, 15. Notice that this sequence for the first two terms has increased from 3 to 5, which is an increase of 2. Between 5 and 9, this is an increase of 4. And between 9 and 15, this is an increase of 6. So consecutive terms are not increasing by a constant each time. The formula for the nth term of an arithmetic sequence is u subscript n equals a plus n minus 1 times d, as shown on your screen. U subscript n is the nth term, a is the first term, and d is the common difference. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. The nth term of an arithmetic sequence is u subscript n equals 43 minus 3n. We are required to find the first 4 terms of the sequence. So let's solve this. We are simply going to plug in the values n equals 1, n equals 2, n equals 3, and n equals 4 into u subscript n each time. So when n equals 1, we have u subscript 1 equals 43 minus 3 times 1. Which is equal to 40. When n equals 2, we plug in n equals 2 into the formula for u subscript n to give 43 minus 3 times 2, which is equal to 37. When n equals 3, we have u subscript 3 equals 43 minus 3 times 3, which is equal to 34. And finally, for the fourth term, when n equals 4, we have u subscript 4 equals 43 minus 3 times 4, which is equal to 31. So the first 4 terms of this sequence are 40, 37, 34, and 31. And now for part B. We are required to write down the 78th term of the sequence. So let's solve this. We're simply going to plug in n equals 78, as shown here, into the formula for u subscript n. And this equals minus 191. And now for another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. We are required to write down the nth term of the arithmetic sequence. So let's solve this. The first term is a equals 3. The difference, or the common difference, d, is equal to 7 minus 3. Which is equal to 4. We now simply plug in the values into the general formula for u subscript n. Remember that u subscript n is equal to a plus n minus 1 times d. And so if we plug in the values of a and d, we obtain u subscript n is equal to 3 plus n minus 1 times 4. And rearranging this equation gives us that u subscript n equals 4n minus 1. And now for part B. We are required to write down the nth term of the arithmetic sequence 52, 47, 42, 37, 32, and so on. So let's solve this. The first term, a, is equal to 52. The difference, d, is equal to 47 minus 52, as shown. And this is, of course, equal to minus 5. We can now substitute this into the general formula for u subscript n for an arithmetic sequence. The nth term is equal to a plus n minus 1 times d, as shown. So plugging in the values of a and d gives us that u subscript n is equal to 52 plus n minus 1 times minus 5. Rearranging this equation and tidying up gives us that the nth term is 57 minus 5n. This brings us to the end of this session. If you have understood its contents, you should be able to recognize number patterns, define an arithmetic sequence, and find the nth term of an arithmetic sequence. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.